Hi everybody, thanks for tuning in again. Now, my pleasure to introduce Divya Puri. Divya is the head of R&D at Fiberight, based in the UK, and today Divya will tell us about their journey and challenges and how they want to end waste. Divya, with that, the stage is yours.
Thanks very much, Christoph. Yeah, so I'm here to talk about Fiberight and our ambition to achieve the end of waste. Our motto, don't burn it, don't bury it, use it, really alludes to the fact that there are so many resources still going to landfill, still going to incineration that we need to recover and return back into the circular economy. And that's what we're trying to do. We're trying to get to this residual waste and recover these resources. So there's a waste and resources challenge. At the moment, recycling is reliant on public participation. It's about the public doing the right thing all the time, and that's just never going to happen. There are always going to be losses in the system. We've got this nice diagram here on the left from Suez, which talks about the sort of different stages of the recycling supply chain. And even in a perfect or near perfect environment, you have losses along the way. So in terms of collection service, there'll be maybe 90% maximum coverage. Separation by householders, you'll have maximum sort of 80% efficiency in the way that it's sorted. You have losses then at sorting, at bulking, and then also at reprocessors. So there's sort of 5 or 6 different steps along the supply chain, and you have losses at each of these steps. So even in a near perfect system, you're still losing about 30% of the material in residual waste. This is coupled further with inefficiencies in the sorting system, and you've got difficult to handle materials, especially flexible plastic bags and things, which are low density, high volume materials, which are hard to collect and hard to handle and process. So there is always going to be resources in this residual waste stream. So how are we addressing this challenge? So what we're trying to do is capture these lost resources, these resources that are going to landfill and incineration that are not even entering the recycling system. We're also capturing contaminated, difficult to recycle materials. So anything wet, anything contaminated with food waste, mixed materials, so sandwich packs or coffee cups with plastic layers, things like this that can't, normally unrecyclable and can't go through normal recycling channels. We can capture all this and recover the raw materials and the components of these wastes. And what we're doing is putting everything on one site. So the 6 different steps that I had in the last diagram, we're doing that all in one location. We're working across the value chain, so it's a sustainable and circular process. Because we're tapping into a completely new seam of material, we are producing a completely new source of recycled materials. So we can help meet the demand that is ever increasing for recycled product to go back into manufacturing. And lastly, we're really working with manufacturers and off-takers to make sure that the products that we're making meet a specification so that we can deliver to a market and we know that there is a home for these different products that we make. So how do we do it? So we've developed our hydrocycle process. We take our raw materials and we debag it, and then we pulp it down to sort of separate out the different material streams and really break down the paper and card and the organics. And then using water as a separation medium, which is completely different to any other recycling process, we're able to separate off these organics from the plastics and metals. If there's food waste in the residual waste stream, that goes via anaerobic digestion to make renewable energy. And we get clean effluent and clean water out. And we have a closed water loop to be able to keep recycling that water within the system. And then we recover the different material streams. So from the process, we get metals, glass, plastic bottles, clear plastic bottles, PET bottles. We also get rigid plastics in the form of pots, tubs, trays. We recover flexible plastics, so plastic bags, film packaging with contaminated packaging, this kind of thing. Paper and card, not just from traditional sources, but also coffee cups, pizza boxes, Tetra Pak, Pringles cans. These sources, especially with fiber, that is not accessible with normal recycling practices. And as I said, if there's food waste in the residual waste stream, then that's also collected in the water and processed via AD. So we built a commercial plant in the US based on hydrocycle technology, and we had these output products coming out. We proved that the technology worked,